Hello, everyone. Welcome to the Frictionless Summit. This is kind of like an unusual community call, a bit longer as well. We could all make it. I'll just do a very, very quick intro just to explain also a little bit how today will go. But then I'll leave the floor as soon as possible to all the amazing presenters that we have. So just for context, basically the idea of this Frictionless Summit was to bring together maintainers, users, and contributors of the Frictionless project to basically discuss all together the challenges that the project is having, priorities for the project, governance issues, and all of this, and trying to imagine all together how the project can move forward with all of us together. So we're many today, and I guess that a lot other will join, but in case you want, there is a document for notes that I can share in the chat. It's here. It's our usual document for the community call. You can just add your name and maybe a short intro if you want right in the beginning. And just to give you an idea of how basically the day will run. So we will start with talking about Frictionless today. So basically, we will have some project presentations from amazing projects out there that are using Friction. So the order is already in the meeting notes, but just for you to know, so we will be having that. The presentations will be a bit short, so around 10 minutes, but there will be time for questions. If you have any, you can either ask them in the chat or you can raise your hand and unmute yourself. After the presentations, time, I warn you already because we have 7 presentations we have to go through, and we want to make sure that everyone gets room to speak. After the presentations, we will have another presentation about the tech we want, which is this initiative from Open Knowledge Foundation, which will be presented by our tech lead, Patricio Del Bocca, that some of you already met. And the idea is basically like we are reimagining a little bit the way that technology is built so that it basically is useful, simple and long-lasting. And then the last bit of the summit will be thinking about friction. And this will be a community discussion on how we can envision the future of the project with members of the community that will be leading the discussion. So those will be Pierre Camilleri, Peter Tesmet, Stephen Diggs, Keith Hugit, Kyle Hosman, and Philip Schum. So thanks everyone already for agreeing to join us for the summit, and especially thanks for those that agreed to present. If you have any questions, once again, you can just write them in the chat, but right now I'll just leave the floor to the very first presentation of the day, which is by Pierre Camilleri and Joan Rischer, and it's about Validata. Pierre and Joan, the floor is yours.
Yes, thanks a lot. Yuan will not join us because he's ill, so I'll be making the presentation alone. Hi everyone, I'll share my screen if I can.
There should be a button close to the webcam.
Yes,
yeah.
it appeared. Yes, thanks. Entire screen. Okay, here we are. So hi everyone, I'm Pierre Camilleri. I'm associate and member of the cooperative company Multi, which is a French company. We offer digital services, and we work mostly with and on open source and with mostly public customers. And I'll be presenting Validata today. So I'm a maintainer of Frictionless Pi, and I'm also the maintainer of Validata that I will present. So I'm a developer, a software developer. So Validata, it's a tool for tabular data validation as frictionless. It uses also the table schema specification, and it builds upon Frictionless to add some features. The first one is the translation of error messages to French, because the main customer for this was data.gov. I will show data.gov is the French catalog for open data. It brings additional check capabilities that I will making a demo of. It brings an HTTP API server and a graphical user interface. So let's start a command line interface that is already present in Frictionless, in the Frictionless tools. I will start to have a quick demo of the graphical user interface. So let's start from the beginning. So this is a public website, validata.fr. It's in French, sorry, it's for a French public. And I can select either my own custom schema here with a URL or a schema from the schema catalog, schema.data.gov.fr. And for instance, if I take the schema for the grants, I have some example data. Yep. And so here I have some schema information. I can validate the data. And I have now a visual interface to navigate the validation errors. So here there is a quick sum up of the errors. So I know that there is a missing column here. And then I know that there are 49 invalid SIRET number, which is a company identification number, and so on. Here I have some suggestions about adding missing columns and removing additional columns. And then I can see inside the data the errors highlighted, and with the Hoover, I can get information in French about the error. So the first aim of this was for the data producer to have a quick and
You're muted.
Pierre, you're muted. Yeah.
Sorry, and also I don't know if it's just me, but I stopped seeing his screen.
Yeah, I don't see it either.
Okay, I don't have the picture to share my screen, so I don't know what happened. Thanks.
I think maybe someone just retrieved your permission to present.
I have just made you a presenter a while ago, but yeah, someone may have changed it. So.
Okay, sorry. I hope it was not a big interruption.
No.
So you should see my screen again.
Yes, perfect.
Yes. Okay. There is also, as I said, an API server, which is right here. So very simple API to validate endpoints, one for local files and one for remote files. So now I'll show how it's used by its main user, which is data.gov.fr. So data.gov.fr is, as I said, the catalog of French public data. And here I've chosen two data sets that should both follow the subvention schema, the one I displayed in the UI. And here I have one that is automatically checked, validated against this schema every time a new version of it is published to the to data.gov. And I can have a direct link to the schema and to the validation report, which is nothing else than this page. And if the data is correct, there is no specific tag like here. So this is really our first use case, and as you can imagine, there are a lot of data sets. So the API is used daily to validate these data sets. A quick look also into schema.data.gov.fr to show that there is a whole ecosystem around table schema here in the French public sector. With also a catalog of schemas. It's not only table schema, but most of it. And the aim is when there are several data publishers to have a standard way of publishing the data, so it's easy to concatenate and to manipulate afterwards. And when this is the case, the schema is created for many different topics. So this is for cycling paths, for counting transport means, for tourism. So really a lot of different public topics. So I mentioned in my introduction that it also added additional check capabilities. We actually made a new repository, which is called FR format, where there are some typically French formats, validators for typically French formats. And every time we add a format in this repository, it is automatically available for validation in Validata with a syntax that I'll show here. So this is a table schema, and I can add a property which is called custom check, and with either a single name or an object with a name and additional options. For instance, here I have a field which is a company identifier, and when adding custom check siret, it will automatically, when using this table schema with Validata, it will check that the data has a proper format for a company identifier. And here we have other custom checks. There is a list of available formats right now in the documentation. So it's kind of a mix of English and French, but we have some geographic validation. For instance, if we want to validate a zip code or the name of a city, or yeah, and then more business specific values. And what's nice about this is that now, if we want to add some specific validators, we only have to implement a format validator in this library, and the link is, and update the library in Validata, and the link is made automatically. There is one last thing that I want you to see around our work on Validata, which is a plugin for Grist. So some of you may know this tool. It's a tool, a spreadsheet tool, open source. And it allows for the creation of plugins. And we've made a plugin to try to imitate the user experience of the Validata user interface, but right inside the tool. So this is actually an open data widget, additional functionality linked with sending data to DataGov or reading data from DataGov. But there is this part which is plugged with Validata, where I can select the schema from the catalog or enter my own schema. I validate the data, so nothing happens because I've already done it before the demo. But then it shows that there are 219 errors. the warnings are again given to the user. So for instance, it says that we should remove the autre colon, which is not defined in the schema. And then there is actually no capability of CRIST to display information of the errors on Hoover. So I had to find a workaround, and right now we have to select a line and see the errors on the selected line. And for instance, délib matière non, this is a typically French new validation FR format. Okay, and I think that's it. So thanks.
Thank you, Pierre. That was amazing. I don't know if you have any questions from the audience for Pierre. You can either write them in the chat or you can raise your hand and unmute yourself and ask it. Amber, yes.
Yeah, that's really interesting work. As someone who works with a lot of data management and identifying quality issues to work with the data contributors, I was wondering how many problems you have with delivering kind of the information that that tool is saying about the warnings, with like people understanding what the problem is. Do you have communication problems there?
So if I understand correctly, is how the non-technical users get the information of technical problems. That's the main challenge we wanted to tackle with Validata. So we tried really to really make the messages easy and with a lot of pedagogy and so usually the users understand what we want to tell them. There are some situations where it's quite hard to give proper information about the error. For instance, if you use regular expressions, then the only thing you can say is the format is not as expected. You can put small description, but a regular expression is by essence a technical object, and there is no way to explain any regular expression easily. So so there are some corners where we had hard times. And when it's the case, then we put extra effort in the description inside the table schema, because mostly the tool is used with table schemas of the schema.data.gov catalog, so we can also add information inside the table schema. So.
Seems like a great interface for that kind of delivery, and I can see that being very flexible for adapting to those challenges. So thank you for your presentation.
Okay, next I think Ethan had his hand raised, and there's also a question in the chat, but we'll go for that later. Ethan, do you want to unmute yourself and ask the question?
Yes, thanks a lot for this presentation. I've been following the work of Validata for a while, and I'm curious if there's ever been a need on your end, or if you've worked at all on a scenario in which someone is not submitting just a single table, but maybe two tables that together have to be consistent with each other, and where you're at with that, if you've dealt with it at all.
Yeah, we were wondering if we should implement a data package into Validata. It would represent some work because the UI was not meant to deal with data packages, and neither does the API. For the data.gov, most of our users use single schemas and single files with the aim to be able to consolidate all the files into one without having surprises about the column names and order and so on. There would definitely be some use cases, but it would rather be the exception than the norm. I try to find one, but my memory fails me. Sorry.
Thank you, Pierre. There's one additional question in the chat by Dan, but unfortunately we don't have time for you to reply live. So Pierre, I will ask you if maybe you can provide an answer in the chat instead, while we move on to the next presentation. Thanks. Romina Coleman, the product owner of Open Data Editor, will be the next one presenting.
Hi, everyone. Thank you also for the space to present the Open Data Editor. And apologies for those who have been present in the Frictionless community call, because I will repeat a couple of things that we mentioned there. And Pierre and Amber, a lot of things that you mentioned resonated with our work, the work that we are doing with the Open Data Editor. Also because we're facing when working with non-technical users. So I will start sharing my screen just to give a little bit of context of what we have been doing. One sec. So we started working on the Open Data Editor 2 years ago, but last year, March 2024, we started thinking about how we could improve the application in terms of integrating the app with the community and also build something that worked for the community. At that time, the app had too many features. So before we start making changes into the tool, we approach people working with data, those with non-technical skills, to ask them key questions. For instance, here are some of the things that the ODE did in the past. Again, a lot of features which make the app confusing for some users. So some of the things that we asked them were connected to their work with data. What are the main problems people face when working with data? How much time do you spend exploring tables? What about the cleaning processes? And some of the things that everyone mentioned were connected to spending a lot of time checking tables, because when they work, for instance, with datasets from open data portals, they had a lot of errors, so they had to use filters and again check cells one by one and that kind of stuff. But also the thing that we also went further and started asking questions about the use of AI, for instance, and those people that were more critical about the implementations of AI had concerns in terms of integrating artificial intelligence in the app. That was one of the features that we had. I will explain more about later. But now I want to show you the app, and I will show you what we are working on right now. Can you see my screen? One sec. Yes, this is. Yes, perfect. These are very similar. So basically, this is the interface of the Open Data Editor. We have two buttons here. When people click here, you can upload CSV or Excel files, also folders with CSV or Excel files, and you can also paste here external data, for instance, files from Google Sheets, because again, during the user research that we conducted, a lot of people mentioned that they were working with Google Sheets, so we thought it would be interesting to add into the Open Data Editor this possibility to paste that kind of tables here. So I will show you how it looks like. This is one data set that in fact, I downloaded from the French Open Data portal, and it's from the deputies. The first part of the ODE, this screen, let the user know what it is with their data. And this is one of the challenges that we were facing when working on the ODE. Why? Because we do not touch the original file. What we do is create a copy of a file in the Open Data Editor folder. So as you can see, the Open Data Editor read the file and detected 4 errors. So if we want to explore the errors, we click here and we see that there's data that it's not expected based on the schema. So if we check the information, we can see errors. And then we see, for instance, here, one of the problems is in row 95. So we can go back, to our data here. And by going to the exact row, we can correct the information. Again, one of the things that we discovered while conducting user research during the whole process is that people also did not want to have this pagination here. So this is one of the things that we are changing in the migrated version of the ODE. We are transforming the app into a lighter app to make it simpler in terms of code. I'm a non-technical person, so I'll explain everything in plain language. But we are also adding some features to make the work with data easier. And again, let me show you one thing. So we can also upload another data set. And if the data set has no errors, the user will see a green dot. Problems and challenges with this. Green and red dot were something that we decided to incorporate in the middle of building the app last year. But when we conducted user research, it was super difficult for people to detect this. So these are one of the things that we are removing in the new version. No one understood why we were using the red and the green dots. They were not visible to them at the beginning of the process. And the other thing is that, as Amber and also Pierre mentioned, we are also struggling with the metadata part of the application, because again, we are using Frictionless, we are applying rules from Frictionless, and everything works okay. But metadata, the concept, is super technical for non-technical users. And for instance, in one of the sessions that we have to test the application, someone said, hey, I saw this button, but for me, that is do not touch, you are going to break something in the application. So one of the challenges that we are having right now and then that we want to address is to think about how we will embed an educational component on the new version of the ODE to make people use the metadata part and also to make it understandable for them. I will show you everything can fail, but this is what we are working on right now. This is the part of the migrated version of the ODE. Let's click here. This is the file that we were exploring in the previous version of the ODE. As you can see, right now it's much easier to explore the data that we have in the application. And this was, again, one of the main challenges that people mentioned were conducting their user research. And also, we have this error report. And what people can do now, I won't do it because we have a bug, but basically they can edit the error that they encounter in their file here, which is not possible in the other version that we have of the ODE. This is something that it's a read-only space. And in the new version, thanks because of the change that we made in terms of the architecture, people will be able to see the errors in a better way, but also edit them here in order not to, again, go back to the original file and start detecting where the errors are located and making changes to them. Regarding the AI component, do I have 3 more minutes, Sarah, to explain this?
Yes, sorry, I don't know if you see me, but yes, you have.
Yes, okay, sorry, yes, I was not seeing you. Okay, so one of the things that we did, again, we thought this can be useful for people, but at the same time, one of the strengths of the app is that this is a local app, so privacy is super important, and it was one of the most relevant components when we interviewed journalists, activists, and people working in NGOs. So as you know, if we connect everything with AI, that can be problematic for people working with data. So we hire an AI consultant, which allowed us to get insights and also start generating reflections about the best way of integrating artificial intelligence into the app. And one of the things that we wanted to do is to let the user know what happens whenever you click there and when you select the AI feature in the app. So here we try to explain that if the person accepts and confirms the action, the only thing that the AI component will do is to suggest names, better names for the columns in their table. After clicking confirm, I won't do it because I need an OpenAI key to use this feature. But basically, we generated a predefined prompt only to, again, just share the information of the columns in the table and allow the artificial intelligence to provide better names for their data. So by doing this, we are trying to make the scope smaller in terms of what we are sharing, but also creating accountability and transparency around the integration of the component. The other thing that we will start working on also in the Open Data Editor is the publishing feature. Right now, again, if you want to publish data directly from the Open Data Editor, you can connect the application with GitHub. And the thing that we are exploring right now is try to rethink about the permissions that the user needs to give to the application in order to publish information on the repository. In the future, we also expect to connect the ODE with SICAM portals so that people can publish data sets on open data portals and also Zenodo. I stopped sharing my screen right now, but I just wanted to mention that the communication component is super important when talking to non-technical audiences. We struggle in terms of thinking how things that were written in the code could be mentioned or translated into simple language for non-technical users. And another challenge is that I'm non-technical, but when you spend too much time on a project, you start making assumptions on the product, on the technology, and the code. So I had to step back a little bit and go to the users again to try to get insights and improve the application. So this is work in progress, but this is the state of the ODE right now. Over to you, Sarta.
Thank you, Romina. Does anyone have questions for Romina? As before, just raise your hand and unmute yourself, or you can ask the questions in the chat as well. Keith, yes, go ahead.
Hey, great presentation, first off, thank you, and Pierre as well. So a couple thoughts. Well, first a question. When the AI is suggesting names to use, do you have an idea of where it's drawing, like what it's suggesting? Because like there are standards that we could try to guide it towards, right? And then we would have some idea of what it's actually suggesting, rather than, I'd imagine the default is it's just gonna use the language model, and then who knows, it'll just suggest like gender or something. But the like rooting it, grounding it in a standard that we all agree is like a good way to call these kind of common fields, would be a good way to guide data towards a more kind of interoperable place. And then the other thing I was going to mention regarding the red-green. So I noticed that also in the last presentation, red and green were used. It's also an issue with accessibility. So like in scientific data visualization, we typically try to avoid it these days. So that's something to consider as well.
Thank you. Maybe Pato can help me with the first question. Pato,
I don't think Patricio is here. Yeah, he is. Yes, he is.
Yes, I am. Sorry, I'm jumping quickly to answer the first question. Good suggestion, Kate. Yeah, we are extremely well aware of like the limits of artificial intelligence.
Patricio, you remuted yourself, so we can.
Or maybe someone muted him.
Yes, sorry. So I was saying that yes, we are well aware of like the limitations and the ethical problems that comes with the use of artificial intelligence. So the work that we are doing is completely exploratory. And that's why also we hire an artificial intelligence like specialist that help us like with discussions. We published like a couple of blog posts about it. So I'm gonna welcome your suggestions. We didn't thought about it, pointing it to standards or trying to guide the artificial intelligence towards like the places we wanted to look. So thank you for the suggestion. Yeah.
And regarding the green and the red dot, you're right. And also we made a couple of mistakes in terms of colors and accessibility that we plan to repair in the new version of the ODE.
Exactly. So Romina, there's an additional question from Ethan in the chat, but I'll let you answer by writing if possible, because I think we need to move on. So the next speaker is Peter Desmet, who will present Camtrap DP. Peter, the floor is yours.
Yes. So share your screen. Great. Okay. Can you see this presentation?
Yes, we can.
Yes.
Okay, great. So yes, I'm going to present CamTrapDP, which is a standard for exchanging camera trap data. So I work with biodiversity data, which is information of where species occur, what it was, when it was observed, and where it was. And the sources for that type of data are citizen scientists, specimen collections, monitoring program, and sensors. There's one huge database out there, the Global Biodiversity Information Facility, which provides free and open access to that type of data. They collect data that is published by institutions. They have over 3 billion records, so 3 billion observations of species. Publishers submit that data in a common data format called Darwin Core. It is all Creative Commons licensed, and what they do with that aggregated data is they allow a cross-data search and API on this, citation tracking, and it's all open source technology. This has been around for almost 25 years now, so it's a very established framework for contributing biodiversity data. And the way you do that is you have to provide your data in a standard, Darwin Core, your metadata and another standard. That together is called a Darwin Core archive, and that is what you register with GBIF. So GBIF is aware of that data set, and then you can publish it. And very often people also republish the data set with new information or corrected information. And they have a tool that is a bit like the open data editor, which is called the GBIF Integrated Publishing Toolkit, or IPT, an online tool where you can publish your data relatively easy to GBIF. So that is the framework we're working in. And one type of that biodiversity data are camera trap data. So camera traps are cameras that take images of wildlife to monitor wildlife. And with that data, we can know the abundance of species, where they are, their behavior. And the nice thing about this technique is it's non-invasive, so the animals are not disturbed, and it allows to collect lots of information semi-automatically. The downside is that all that information also needs to be processed, because you get lots of images, but that doesn't mean necessarily that you know what species were observed. Luckily, in the camera trap world, there's data management systems that really help researchers process that data, and AI really helps there with species identification. And there's a number of those systems, but they don't really talk well with each other. They all have their own formats, and your data, if you export it, is not really compatible with data from another system, making it harder to do research. There's also a lack of suitable standards, and Darwin Core would be a tool to, or a standard to express this information, but it's not really an ideal fit for the people within the camera trap community. So that is why we then started with a group of people to develop a standard for camera trap data called CamTrapDP, which stands for Camera Trap Data Package. It is basically designed to capture all the essential data and metadata for a camera trap study. And it's both a model and a format for exchanging that type of information. And the model, without going into too much detail, is you have a study and you have the metadata about that. You have the deployments of your cameras, is when and where you put those out. You capture lots of media files, and then you have the observations of what you observed or what the AI has observed in those media files. And for the format, we adopted to, or we decided to build upon data package. So a CamTrapDP is in essence a data package, which makes it easy to understand. It's immediately machine readable. All the software that exists for data packages we can immediately use. And it's also extensible, which is really great for camera trap data, and people can add their own tables. So it is both very domain specific and also highly interoperable, which is exactly what we want. The standard itself consists of a profile where we define the metadata, which is extending data package with more terms that are specific to camera trap data, and then 3 table schemas where we define every field that needs to be recorded for a deployment, a media file, and observation, the field types, any controlled vocabularies, relationships between the tables, all of that we could just define as stable schemas. All of this was developed collaboratively with a huge group of people, and we used GitHub for storing all the code for the standards. That also allows us to version it. And we also collaborated on Git2 discussion, discussing issues, having pull requests, automating tests, and all the documentation, the source files that are there in GitHub are then rendered to a website, so the less technical people can also explore the standards. So the other really important part with CamTrapDB that made it quite successful is to have all the software developers and the whole data pipeline on board, from the data management systems, which are now exporting data as CamTrapDB, to the tools, whether it is visualization tools, analysis tools, AI training tools, to have that as an import format. And it is now also adopted by GBIF, this huge database, as an alternative to Darwin Core Archives to publish data directly to GBIF in CamTrapDB. So you don't need to transform it even further to have it published to GBIF. The outreach part is there's the website for CamTrapDB where people can find more documentation. We also write a scientific paper about this. Initially, I thought that's not really necessary, but we reached a huge audience that would never look at a technical website that way, of researchers that are involved in camera trap that then became aware of the standards, and lots of presentations at conferences or reaching out to people to really make this standard something as a common language between everything working in this community. We also contributed back to Frictionless because we had some ideas on how to improve the standard that we rely upon. So that is by proposing changes to data package. And I'm now also maintaining the Frictionless R package, which we use a lot. And we thought it would be a good idea to have a good R package to read and write data packages. And to broaden the scope a bit, this was actually inspiring to GBIF. They are planning, together with an organization called the Biodiversity Information Standards, which is a non-profit designing biodiversity information standards, to adopt Frictionless for a new version of Darwin Core Archive, which is going to be called Darwin Core Data Package, and really builds upon Frictionless standards. So I would say that in 5 years from now, lots of more biodiversity data is going to be submitted to GBIF, building upon Frictionless data standards. Thanks.
Thank you, Peter. Well done and exciting. We can't wait to see more biodiversity data packages out there. Do we have any questions for Peter? You can, again, just raise your hand and unmute yourself or write them in the chat.
Thanks, Keith.
Okay, if not, I think that some people are writing, so I'm assuming, Peter, you'll have some questions that you can answer in writing, possibly. Maybe we can just move on to the next presentation. So up next is Nicholas Kellett, who will talk about deploy solutions. Nick, the floor is yours.
Hi, everyone. Can you hear me?
Yes, we can, and we can see your screen as well.
Perfect. I'm just going to turn on my screen as well so you can see me. I'm going to be working off the other screen. For those who may not know, it's probably all of you, we build software solutions, and since 2019, we've been focused on climate change specific research and development, and even more specifically on what's called physical risks and resilience. So that does include disaster response, but more it's all about how do you protect physical infrastructure or financial assets, somebody's home, factory, from the changing climate risks, which could include more flooding, more fires, heat droughts, pests, and things like that. So that's become a focus of our company. And so what I'm showing you here, although the title I think talks about citizen science, we have used Frictionless for that, but this particular application that we're building right now, it allows somebody to upload a list of their physical infrastructure, if they're a municipal government, for example, or if they have a list of financial assets under management. So in their financial portfolio, they may be real estate investment trusts, or they may be people who have factories, and they want to know what are they exposed to, what possible damages could occur to their infrastructure or their assets, and what can they do about that. So that's what this application is about. Basically, if you were to upload your portfolio using a CSV file, which you can do over here, let's say, a list of Ottawa hotels, maybe, my financial assets include a list of hotels that I own. And we think the primary way people are going to upload this information is through a CSV file. So you can download a template, but basically you're going to bulk import all your information. And so obviously we want to make sure that that data is clean, and I'll talk about that shortly, but Frictionless is clearly an important part of that. Here's an example of a set of assets inside the Ottawa Malls portfolio that I've created for this demo. And if I were to click on some of these particular locations, then it would tell me what hazards we're exposed to. So again, flooding, fire, drought, and the like. But the important information that you want to convey to a user is, what do you do about that? So if a flood could occur, what actions could you take to reduce the risk? And it's going to track the information as well. So there's a whole application here. It's written in .NET. I'll talk about the code shortly. But the key point is that the way that people are going to interact with this is through CSV files and bulk loading this information. And then we also, in order to provide the guidance, the actions and the impacts information, and the questions we should ask you, and so on, and the list of hazards and the list of UN scenarios, and on and on and on, we need to be able to bulk load lots and lots of data. So what's happening behind the scenes is we realized that we needed to create a whole bunch of different what are called domain entities. They're concepts that are key to this application's domain, which is physical risk and resilience for climate change. And that long list of things that we need to take into consideration includes the portfolios that I talked about, but portfolios have assets, and we want to evaluate what the hazards are, and we want to evaluate what the various climate scenarios are, and so on. And so we realized as we were building all these things out that we really wanted a way to standardize a lot of the metadata fields or data fields that we were going to import and store in our database. And so we came up with a standard way to do this. Basically, we're now looking at a SQL database tool, and we're looking at an example table. This is where the asset information that we uploaded would go, and that's again this information here. So a list of assets, in this case, again, it could be a hotel or a farm or a factory or condos, something like that. So what we did is we standardized a set of data that we could always guarantee would be present for any of these things. We need to know what its unique identifier is. We want to have information describing it. We want to have name information. We want to know who created it, when it was last modified, if it was deleted, and so on. And so there's about 18 to 20 of these, what we call core columns, that we would always have no matter what it is you're talking about in our application. And then on top of that, we start building extra properties which are relevant to that particular domain entity. So an asset might have a financial value attached to it. A portfolio might have a count of how many assets are in the portfolio. A UN scenario might have the RPC number or a link off to the UN information on their website or something like that. So these things are different. So what that ends up meaning is that we have to have a standard way that we can store this data, and it has to be reflected in our application. But effectively, we also have to ensure that when we're bulk uploading through a CSV, these values are supported and validated and present as well. And so in the course of building this application, we were also constantly evaluating, what these different concepts are and which properties we need and how they link to each other. And we're constantly making changes and adjusting based on user feedback or based on the work that we were doing or new research that we found, or even just trying to build the application. And so although we wanted to use Frictionless, the schemas that we wanted to follow were rapidly getting out of date and out of sync with each other. And we wanted to make sure that they were always in sync. So what we ended up doing right inside our code is we actually created code to generate frictionless schemas based on the properties that we're supporting and always supporting those core properties. So when we run the latest version of our application, we actually end up producing, sort of as a byproduct, a folder which we call Frictionless, which contains these different pieces of code inside it, including the list of frictionless schemas. So basically every table that you would see in our application or in our code would have a corresponding frictionless schema created. And I'll show you what that looks like in Visual Studio Code, and maybe it's a little hard to see, but basically we could go through each one of these schemas in turn. And one of them is on the UN scenarios, one is the list of assets, one is the classes of the assets, and so on. And then if you look at these custom columns that are present in the frictionless schema for asset, you can see that in this case, we want to know about an asset type and an asset class. But as we go down the list, we start to also see these core columns that we talked about. So we can make sure that when we're bulk importing the CSV that we're validating to make sure that it does have an appropriate name. It does have, the cultures allows us to do English, French, Spanish, and other things. That we have the username who created it, whether it was deleted again, the core ID, and so on. So what we've basically done is we've ensured that there's a complete flow from the ability to bulk import in the system all the way to the application displaying this information, down to the database where we store it, and then making sure that that's present in Frictionless for validation. So I know it's kind of a technical presentation, but effectively what's happening is we're embedding Frictionless as a key part of our data import strategy. In the application, the user would probably only really see the part where they upload a portfolio with their assets, but we as developers are constantly uploading hazard information and lists of documents that are relevant and things like that. And again, a key point is that in order to keep these functionalities in sync with Frictionless, we've actually created code to generate the frictionless schemas. And we've also standardized the list of common metadata fields that we think are needed and made sure that those are present in the schema as well. So we're kind of building the plane as we're flying the plane, if that makes sense. But it shows how important Frictionless is to us that we're going to go to the trouble of doing that. And I can tell you it's been helpful over the last month or so of testing, because we've been trying to bulk import lots of stuff and wanting to make sure that Frictionless is a key part of that. The other point I'll make is that we're contributing to a group called Linux Foundation's OS Climate, Open Source Climate. And so at the end of April, when we finish our application, we're going to backport a lot of the data structures that we've created into an open source repository, which is available on the OS Climate org under an Apache license. And we already have an old version of this. You can see it under source. Is it showing properly? Yeah. So in CSV, we only have one example of a schema for Frictionless. It's a bit out of date, but we'll be adding all the other ones, so those will be available. And there'll be a corresponding database schema which people can use to create a sample database that contains all of these fields as well to get them started. So our hope is that this can help standardize the fields that are necessary to do a lot of the web application development or data design or database design using these common fields for climate change or other purposes, and that Frictionless will be a key part of the mix, and that functionality, including those schemas I showed you, will be available under an Apache license. So I kind of blasted through that. Hopefully that's of interest and made some sense. I don't know if it did. Anybody have any questions?
Thanks, Nick. That was great. Again, if anyone has questions, just raise your hand and then you can unmute yourself, or you can write them in the chat. So I see some people writing. So what I would suggest, Nick, is that maybe you can just keep an eye on the chat. Probably there are some questions coming your way. And sure. Sorry, but because we have like a really packed time, we'll just meanwhile move on with the next presentation, which is Phil with data curation with frictionless. Phil, are you there? You can, yes, you are. So the floor is yours and you can present. Thanks again, Nick.
Oh, wonderful, thank you. Are you able to, oh, there we go. Are you able to see that okay?
Yes.
Wonderful, okay. So thanks very much for the opportunity to talk to you a little bit about a project that that we have been working on that I think is much more kind of broadly relevant, the work for which is much more broadly relevant, specifically for sort of biomedical research and sort of even more broadly than that. It would include epidemiological research and some social science research. I thought I would just, some folks may be familiar with this, but this is, you know, a quick overview of NIH's new data sharing policy, which went into effect in January of 2023. And this really represents NIH for the longest time. And oh, I should have very clearly said that while I'm going to be talking about work that is sponsored by NIH, I am not affiliated with NIH in any way. So I just want to make that super clear. They've of course been facilitating data sharing for a long time, but this new policy really represented a sea change for them in terms of the breadth and depth of what it actually covers. Namely, it now applies to all research funded by NIH that results in the generation of scientific data, with only a few exceptions. They now are explicit about the fact that data should be made accessible as soon as possible, and ideally at the time that a publication is created, as opposed to you know, far down the road. The policy itself and materials that they provide along with that really encourages use of best practices for data management, and in particular is very oriented around the concept of fair data, so findable, accessible, interoperable, and reusable for folks who are familiar with that. It also includes not only the data themselves, but code and other materials that might be necessary for replicating the research. And then finally, while they're very specific about what I just mentioned, there are many different repositories. NIH themselves support a number of different repositories, and then there are several other repositories where NIH-funded researchers can submit their data. And those vary a tremendous amount based on their metadata models, their levels of curation, and that sort of thing. And so that's really a critical feature of sort of what it is that I'm talking about and of what's required in order to, you know, in order to accommodate that. So that policy went into effect in January of 2023, and even though NIH has and continues to do a tremendous amount to sort of support investigators in complying with that, the fact is that the majority of investigators still at this point are unfamiliar with data sharing methods, and with the whole idea that by adopting best practices for their sort of data management, they not only make it easier to comply with the data sharing requirements, but they can also improve the quality and efficiency of their own work. And this is where Frictionless comes in, because in so many ways, it is ideally suited to the sharing of NIH-funded and other biomedical research data. You know, it's simple, it's easy to use and to understand, and that's key, obviously, for the majority of funded investigators who might be very technical individuals, but not necessarily when it comes to computer science or informatics. The frictionless standards are built on top of other standards, and the software is free and open, which is sort of critical for this kind of work. It's agnostic with respect to the data management and analytics software. And that's critical because there is a lot of domain-specific data management and analytics software. And so the wonderful thing about Frictionless is that in principle, it can plug into all of those. Frictionless's metadata support FAIR data very, very well. And then finally, Frictionless is flexible and extensible. And so that's critical for supporting those repository-specific requirements. Remember, I spoke about how variable those can be. And in that respect, Frictionless is quite distinct among other sort of systems and approaches for data sharing, some of which are quite good, but are quite prescriptive and limited, and therefore limited in terms of their reach. And if you take anything away from what I say today, it's the following thing. I think that this is just the most fantastic opportunity, both to help NIH-funded investigators comply with this data management sharing policy, but also to have really a substantial impact on data sharing within the biomedical sciences and expand the use of Frictionless. I'm going to talk briefly about an example, but there are several. This is just an example for, a quick presentation, and something called the HEAL Data Platform. The HEAL Data Platform is a platform which myself, but not really me, a huge team of people at our center has built, which facilitates and supports the use of the data collected by, at this point, over 1,000 studies within something known as NIH's Helping to End Addiction Long-Term Initiative. This is their approach to tackling the opioid crisis within the US and beyond. The HEAL Data Platform is a data hub that provides search and discovery over those studies and data sets, provides secure data access, and then also cloud-based compute for data that are located in about 24 different NIH and other repositories. So the HEAL Data Platform does not store data, it merely acts as a hub through which those data can be securely accessed. It's built on something called the Gen 3 software stack, which was created, is developed and maintained by our center. And at this point powers about 24 different data platforms holding over 25 petabytes of data at this point. And I would be remiss if I didn't point out that our HEAL Data Platform is really part of a much larger effort known as the HEAL Data Ecosystem, which supports data sharing and data reuse among HEAL-funded research. This is just a quick graphical overview of what the platform sort of looks like, non-technical overview. But in a nutshell, at the top left, these are investigators who are generating data. And as I mentioned before, those data are deposited into, these are just an example, but it's actually, the list now is over about 24 different data repositories. You'll recognize some of the ones that are there and how variable they are. At the same time, those investigators provide metadata about their studies and their data to a variety of places. Things, NIH Reporter, clinicaltrials.gov, some folks may recognize what those are. And so our HEAL Data Platform not only provides access to the data from those repositories by interoperating with them, and if anyone's interested in how that works, I would be glad to provide information about that through Slack or elsewhere. But we also are able to pull in metadata and link them to those data sets from those different sources. And that provides a really rich experience for the secondary data user. Just to be a little more specific about some of the things that we've done with Frictionless, one of the first things we did is we created a number of metadata schemas that obviously are based on existing metadata schemas and simply extended for our purpose. And in particular, the variable level metadata schema we created is based on, it's just a simple extension of the frictionless tabular data schema. So a lot of our approach here is very similar to what Peter was talking about with CamTrap DP. By extending frictionless, we don't reinvent anything, and we're starting with a really solid base so that all of the existing software can be used with what it is that we're doing here. We've created an SDK for generating these VLMD files, both from data collection systems, and I think if I was looking at the users here, there's a fellow Mike Krantz who did some of the formative work on that, generating those automatically either from data collection systems, and REDCap is a common one, but there are several, or from existing data sets. And so that makes, both of those make it real easy for a data producer who may not be familiar with the concept of metadata to create metadata, and that is creating metadata that are pretty likely to be well aligned with their actual data, as opposed to efforts to get metadata manually from folks where those can vary quite a bit from the data. We've heavily used the existing Frictionless Pi package and library. For example, we've used the pipelines feature to create pipelines for translating data and metadata specifically into formats required by some of the repositories that we interoperate with, and then also into a common format which we refer to as the HEAL Common Data Element format. That's, gosh, it's several hundred common data elements now that HEAL investigators are required to use. And so these pipelines basically make it real easy, not only for people to submit their data, but then to achieve a common sort of, because the repositories themselves all differ in terms of their data models, but this allows us to achieve a common sort of harmonized standard for the secondary data users themselves. We've also done a lot to support the use of frictionless among investigators. Specifically, we keep current with the latest version of Frictionless Pi inside of our cloud-based workspaces. And we also provide investigators with help in creating data packages under the new 2.0 standard, and the new datapackage.org website and the new standards have been invaluable. Actually, they came along at just the right time for us. And then finally, we're working to incorporate Frictionless into the Gen 3 software stack. I want to leave some time for questions. So just very quickly, based on what I've said, these are some of what I think are some of the key areas for future development to continue to move sort of the work that I've described along and really capitalize on these current opportunities. The first is, while it's straightforward, of course, to extend the frictionless metadata models, it would be really helpful to have some even clearer guidance and possibly established sort of community standards for how that's done. I think there's maybe still a little bit of work to be done there. We're all clearly capitalizing on that flexibility, but we want to, and extensibility, we want to make absolutely sure then that the tools we create, that doesn't create, unnecessary problems when you use those tools. Software support for creating frictionless data packages from various systems. I spoke a little bit about that, but then also software support for the major analytic packages in these fields. I think Peter's Frictionless R package clearly is the premier example of terrific support at this point, but analytic packages such as Stata, SAS, and SPSS are quite common. And one thing we've talked about, maybe we'll talk about later this morning, is beginning to build all of those native libraries on top of a common core library. I think that would be tremendously valuable and efficient. Translating between the frictionless metadata standards and other kinds of models. So the DDI, Data Documentation Initiative, is just one simple example. There are many. a lot of repositories have standardized on those. And for them to really make use of Frictionless, we have to be able to seamlessly go between those. And this would not be a tremendous amount of work. But again, it sounds to me that based on the presentations we've heard so far this morning, that there's a lot of work, one-off work by various groups doing that. And if we could pull that under some more sort of centralized effort, I think it would work better. And then finally, Romina's tool is a perfect example of this, but most of what we're talking about here is getting non-technical, or should we say non-informatics technical folks using Frictionless. And so, any additional education and support here, I think can benefit all of us who are making use of Frictionless. So I'll stop there. Glad to take questions.
We have time for maybe just one quick question. If anyone has it, just raise your hand and unmute yourself. Or you can always write questions in the chat as well, of course. I think you might be some questions in the chat, Phil. So probably just keep an eye on that. And great, because this last slide that you shared also will provide a lot of food for thoughts for the later discussion about the future of Frictionless. So that's a good introduction. But now let's move on to the next presentation. So we have Adam Shepherd and Amber York, who will present Bicodimo. I'm unsure whether you both present or one presents, but I just put both names. Also,
hi there. Yeah, I'm happy to present here. Let's see, how do we do this? Take presenter. Is that what it is?
I think you should have yeah, exactly, share screen.
Let's see. I'm at a loss. Can someone help me? Oh, there we go. Yep, great, got it.
You found it? Yeah.
Yes, thank you. Green. Okay, great. Can y'all see that?
Yes.
Okay, great. Hi, friends. My name is Adam Shepherd. I'm the technical director at the Biological and Chemical Oceanography Data Management Office. Thank you so much. I want to talk about the frictionless use cases that we have at our data management office that has been around for the past 19 years. We're primarily funded by the National Science Foundation here in the US to work with all of the researchers that they fund to go out and do oceanographic research. And so essentially what we do is we sort of serve as this role to make the data that those scientists collect accessible to the public. And so those researchers, once they're done with their data collection, eventually submit that data to us. We help them sort of package it, describe it, get it a DOI, and unarchive it so that the public can then find it and reuse it. And our office sits right now at the Woods Hole Oceanographic Institution in Massachusetts. And so just to give you a sense of our scope, we have data sets all over the globe. I think our data sets now are just reached over 7,000, a whole bunch of different data types. I would say most of them are tabular, but we do get some images, video, and some other proprietary data formats. But our office sits here in support of those researchers throughout the entire data lifecycle. So that really just comes down to helping them write their proposals, the data acquisition, analysis, through contribution all the way to discovery and access, data reuse, and preservation. But today, I really want to focus on the places where Frictionless has an impact on the ways that we perform those sort of data stewardship activities. And that really just sort of hones in on contribution, publication, and access for us. And so if we dive into that a little bit deeper, For our researchers, contribution means the way that they submit their data and metadata to us. That's primarily an activity driven by them externally to our office. And then internally, once they've submitted and gathered their metadata for us, that data set moves into a curation phase where our staff is activated and actively working with the researcher to package that data as best we can to support fair and care for the community downstream. And that ends up resulting in a publication phase where we're packaging that data and metadata for a DOI, and then ultimately leading to data access here, where the public can view that data and make a decision about whether they want to reuse that or not. Okay, so in the contribution phase, we have a tool at submit.bicodemo.org. This is where our research community comes and can submit data to us, and they can sort of build out their metadata profile, describe the people, the locations where that data was, upload data files, and really sort of build out that description of what their research collected. And essentially what's happening behind the scenes is this interface is building a frictionless data package for them. And so we are an old bird. We've been on data package version 1 for a little bit now. And so essentially what's happening, like as I said, in that interface is building out one of those data package.json files. But the story doesn't end there. What we get submitted is a various flavor and sundry of data with different formats, color codings, merge cells, images, video. And so this is where that sort of external submission moves into a curation phase for our staff, where we're helping that researcher take their beautifully decorated data sets and turn them into something that's regular, consistent, that can be used for the community downstream later on. And that hopefully results in a CSV file and a beautiful metadata landing page. And so to get to that point, and I think Phil talked about data package pipelines, we're using that same package and technique to take their beautiful data and apply what's called a pipeline spec.yaml for us that describes the transforms that our staff want to do on that data set to end up with that regular and consistent CSV. And so that data package pipelines, the result of using that is two things. One, a new data package.json and a new CSV. And the data package.json describes that CSV for us. And so what's happening here is we've got the submission that has a data package that the researcher was building in that submission tool. We're applying the pipeline.spec, and out comes a more curated resource, a data package, and that new CSV. And just to give you an example of what this curation looks like, we built a tool called Laminar that you'll see in a minute here. And essentially what we're trying to do is just as a data manager, describe the transforms that need to happen here. And so in this case, we're talking about a lat long that was provided in one field with in a specific format. And one of the transforms that we would perform is to break those out and provide them in a format that's easier to reuse downstream. And so on top of data package pipelines, we've built a user interface for our staff to build out that YAML file, execute it, and ultimately end up with that curated resource. And so if you remember here, Laminar sort of sits in the middle, building out that pipeline spec to end up at that curated resource, which then leads us sort of the next step. So we're not yet done, and we need a way to take that curated resource and bring in all that rich metadata that we collected during submission phase into ultimately a DOI package here. And so again, we're using data package to build that DOI resource and end up with a landing page for our data sets. And if we were to look at the access data set drop down on the upper right, you'd be able to view that data set. And that would look something like this, where we're essentially like looking at the data package for that DOI, looking at the schema, pulling out what fields are in that, data package or describing that data, and we can decorate it with the units and descriptions. And very similar to the editor that was shown earlier, this is an interface where you can sort of inspect the data and query individual columns. So let's say you wanted to look at temperatures greater or less than a certain digit, you can do that. You can sort and filter and just sort of inspect the data set, and then of course download it from up at the top. And so in a nutshell, that's sort of like what we're doing at BecoDemo, but I think the real value is why we're doing that, why we picked Frictionless. And I think Phil and Peter and Keith and a number of other folks touched on this a little bit. But for us, when we were introduced to data package and Frictionless, it really came down to data transport for us. So we need to move data from the researchers in their submission phase to us for curation, and then eventually to the publication, and then to an access. And data package sort of sits as the intermediary between all these phases for us. And that is so huge because it provides what I think is essentially that data package becomes an abstraction layer between our software systems. And this is critical for an office that's on federal funding. It means that the sustainability of our software, as things change over time, as software sort of hits end of life, that we have a mechanism for plugging and playing new software, rewriting it, and reducing the sort of technical debt of our office as software needs to change and needs to be replaced. So that's a really just overview. Just again, wanted to highlight that we're essentially on data package version 1. We definitely need to upgrade so you for the transforms. Happy to give demos if you, but I kind of wanted to open it up to questions. You can find more information at our blog that I've put here on this slide and in the Google Doc notes.
Thank you, Adam. Amber, you have a question.
I just want to add one thing too. We didn't really get into it here because of the limited time, but we also have an internal tool we're using based on good tables for validation and custom checks for like our conventions, which has been extremely helpful. And as you saw with that processing pipeline, it's been a really valuable tool for us for consistency and reducing custom scripting as a data manager. But it is a lot of work on the communication side too. So I've been really interested in your other presentations of people that have put a lot of that in front of the user. And that's kind of what we're thinking about too. So this has been really valuable to see how you guys have approached that. And I have some comments later about barriers to entry with the format to even get it into frictionless packages. And hopefully there's time to talk about that with everyone later.
You might be getting some question in the chat, and that's definitely something. Oh, Keith, you have a question.
Hey, great presentation. I was wondering if any of the work you're doing with the pipelines aspect could be moved or would benefit other efforts and could be pushed upstream.
Yeah, that's a great question. One of the things that we've considered is given that pipeline tool to the submitters, like maybe sort of teaching them or giving them the capabilities to make those transforms and use the submission process as a teaching mechanism about good data management practices. We haven't gotten there yet, but it's sort of on the docket. Is that sort of what you were hinting at, or maybe you had other ideas, and we'd love to hear that.
I was thinking, it sounds like you're writing code to do some of these like fixes, right? Process the data. And I wonder if those same kinds of things that you're catching on your end would also be beneficial to like share more widely
Yeah, sure, absolutely. I think I put a link into all of our pipelines. I think we have about 30 individual routines. I'm happy to share that and pull that up here. Let me.
Yeah, so we have a lot of, some of the standard ones in data package pipelines, but we do have some custom steps that Conrad Schloer, the wonderful developer we work with, has implemented for us. That might be what you're hinting at too. I could see that, yeah.
I wonder, this also makes me wonder whether there would be use for like extending the kind of the transformation functionality in the Frictionless Python package to have both like built-in transformations, but then some kind of support for like extending it, kind of custom transforms that could be built into the pipelines. But that we could discuss later. It's a little off topic.
I just threw the link in the chat and then also in the Google Doc there for anyone that's interested.
Thank you.
Yeah, just real quick, I think, Amber, we've probably been using pipelines for the past 4 years now, and it seems like these 30 or so have covered 99% of our use cases. I don't think we've...
Yeah, it's actually covered a lot more than we'd expected. We thought we would have more edge cases, to be honest. But as Adam mentioned, we haven't been rolling with the changes of the newer frictionless releases. So, ours are based on anything that may not be compatible with some of the bleeding edge things. So that's something, we've discussed too, is the benefits of updating to get some of those newer features, particularly around processing larger data sets and things, and some other cases that we could see improvements from upgrading.
Okay, I think we'll be moving to the next presentation, but if anyone still has questions for both Adam and Amber, you can just write them in the chat. So Ethan Welty is the next presenter and the last presenter of this Frictionless Today section. He will be talking about global and glacial temperature database. Ethan, the floor is yours.
Ooh, sorry, 1 second. And actually, I'll be trying to address kind of generally how we use Frictionless and tools that build on it, generally for all Glacier data sets. So I'm looking for...
You should be able to share your screen if that's what... yes, yeah, you found it.
Yeah, okay, but the problem is I need to share, not just a... Maybe I'll just share my entire screen. All right, yes, sorry. So I'm Ethan Welty. I am basically single-handedly responsible for data management and software development at the World Glacier Monitoring Service, which sounds very fancy. Maybe it is, but it's really just the equivalent of 3 full-time people. So we're quite small as a data repository. And it's a service that was initiated in 1895, so a lot of history. There is a worldwide network of observers, so glaciologists in every country where there's glaciers to observe, that are making observations on glacier change, mass balance, and length and area, and also temperatures we mentioned, glacier thickness. And we are responsible to curate, so either from the literature, also we're receiving submissions from hundreds of different people every year, and build these comprehensive global glacier data sets that are these living data sets that, well, one of them is going on since 1895, quite literally. And then we also do sort of data analysis, and we're responsible for reporting to the UN and IPCC, UNESCO, WMO, all these big national organizations regarding the state of the climate, the state of the glaciers in that climate. And so I have the climate stripes at the bottom showing basically sort of glacier mass loss over time. So red is negative loss, blue was sort of global glacier mass gain, which we don't see anymore. And I actually was thinking, so I've taken on the role of really sort of automating and improving how we manage our data sets, and we're a small team, and so there's a big focus on something relatively lightweight and sort of avoiding repeating ourselves, so that we can ensure quality and reliability, but without breaking ourselves. And so that's basically what brought me to Frictionless. So I was looking for just an approach where we have metadata that we just with which you can describe the data, both because we need to do that anyway. Our users will require it, but also so that we can directly build on that to actually test that the data is as described in the metadata. And I've basically taken this general concept and go on in my own various ways with that. And I'll try to give you a feeling for that. I actually have a little demo. That's the link here. And we'll see if we can play with it a little bit. And I'll put the link in the chat. So the process so just as sort of context is mostly I'm working with tabular data, but often multi-tabular data. So data that's coming in that describes, for example, maybe a glacier, a hole that you drill into a glacier borehole, and then maybe the measurements that have been made in that borehole. So you can imagine two different tables there. A very sort of cartoon example of sort of the philosophy that I'm both implementing and also kind of promoting in the community is that, okay, write your metadata. So of course, in this case, this is a frictionless data package would fill this role. Then you have your data. And already you can build on existing tools. So this, you already know, I'm preaching to the choir. So frictionless validate data package. But maybe you're doing this on a Git repository on GitHub, and you can do some configurations to run those same tests on GitHub. So basically in the cloud, whenever changes are made to the data and metadata. And then maybe you want to publish your data set. And here, just as one example, that maybe there's some Zenoda metadata. So Zenoda is a data publisher that connects well to GitHub. And you could imagine building the Zenoda metadata from the metadata, maybe in a script so you don't repeat yourself, and ensure that they are in sync. And then you can quite easily, through this integration between GitHub and Zenoda, publish versions of your data set. And so in the demo, can you still see my screen?
Yeah.
Yeah. So again, we have a data package metadata file. And so as you know, we could do frictionless validate, and it would work. We have a sort of little, very simple case. But then you're going to, at least for me, I quickly ran into the issues of this. There's this tests that maybe you can express in a metadata standard, frictionless or another. And so from a software development perspective, maybe you can write just unit tests on your data. And then this example uses basically PyTest, which is just in Python, how you might write unit tests for software, to run these additional tests on your data. And it could be things like, well, here it's whether rows are sorted in a certain way. So that's about sort of data storage, or it could be some implied expectation of the data. So we have two tables. There's the date where the borehole was drilled. And then in the other table, there's the date when the measurement was made. And that measurement can't possibly be before the borehole was drilled. It'd be impossible. And so these are some of the things that, and I have hundreds of these examples where we can still want to check something, or maybe warn, or a statistical threshold. Now, I found that once you have hundreds or many hundreds of these types of tests, it becomes quite difficult to manage that way. And so I have actually, building on Frictionless, this package called Validator, which allows me to kind of in a more concise way write, basically I have a sort of taxonomy of checks that apply at a multi-tabular single table, but across columns, or in a single column in a table checks. And I can also express them then once I've sort of defined my terms by basically Python functions. I can refer to them in these sort of concise metadata file that describes a pipeline actually. So it can test the data, but can actually make modifications to the data as well. And then printing out reports, or even, so this is something that we use internally. It's a lot of data. So, you know, some other people on my team, they're quite comfortable using Excel, sort of spreadsheet environments. And so one tool we have is you run a data submission that we receive, you run it through all of these checks, and then the output is maybe a report, but also a new Excel file with all of the issues highlighted, in which you can directly then make maybe call the submitter or make the fixes yourself if you understand, and then rerun. And so this is data that's new data. It could actually be suggestions for data updates, so actually patches to an existing data set. So there's also sort of visualization of what's changed, but it's all done in a very cheap way, I guess you could say, just by writing these reports to files. So it's not like a big online platform, because we just didn't have the capacity to maintain that or build it. So what does that look like here? So in the demo, it's just, I wrote a couple custom functions that show the sort of fancier stuff. So that's basically running all of the tests are defined in the metadata in Frictionless, the data package, because those are the custom tense checks again, but sort of written in this sort of validator pipeline. And it's also has, I basically started, you can convert a data package or anything below that to a validator sort of pipeline schema. So it's including all of those as well, and then the custom ones. Now, the other thing I've used a lot and I really love is just if you have the central metadata file. I mean, it seems obvious, but I think Frictionless has done a great job of really promoting this approach, is you can render documentation. And so I've done this a lot because it becomes impossible to maintain these really, really complex documentation for some of these data sets. So an example is for our main data set, which has many different tables. Here's an example. This is a rendering from the metadata using Jinja, in this case, Python templating engine, to build actually Markdown, which then gets converted to PDF from via HTML, with links between. You have lots of inline links to jump between different columns and tables, and our users have found this very useful. And so in the demo. So that looks like, I think it's build readme. And it's based here, I actually wrote this directly HTML, and you just inject in information from the metadata file. And that looks like this. So, simple, but it gets the job done. And you can be sure that it actually matches the metadata, which you've tested to match the data. There's this other tool that I constructed, which is that we require a lot of data submissions. That's a big, and often people don't want to build data by hand. They're building it by hand. It could be very small data sets, basically, that they're constructing, they're sending to us. And so it's very helpful for them to be able to have some sort of template. And here, again, building so Excel and Google Sheets templates directly from the metadata, and in a way that actually supports multiple tables and foreign keys between tables. And so in our demo, so that's, I think it's just build, I'll just do the Excel version. Oh no, it's called Excel template. And okay, actually, I'm cheating. I already have it built, and I was playing around with it. So we have our two tables, we have our columns. Information about each column is added in the header here. And you can fill it out. And for example, here, and it's checked a lot of indirect validation. Not everything you can do, of course, in the spreadsheet, but you can already get a good start. So like if you start here and it's going to tell you, well, these are required. So now it's red because you've started a new row. Yeah, that I'm going to stop there.
Thank you, Ethan. Well done. Do we have questions? Again, you can raise your hand and unmute yourself, or you can write the questions in the chat. Patricio.
Hey, Ethan. Thank you for the presentation. It was like really nice. I have a question because I was checking like at the GitHub repository, and you compare the validator package, Python package with Frictionless. And one of the points that you put is like this that Frictionless is slow for large data sets, which is my experience as well. So can you talk a little bit about like performance there?
Sure. Yeah. Yeah. It used to be. It's gotten much better, I have to say. But it's still, for when I'm dealing with millions or hundreds of millions of record, it's not really an option anymore. Yeah. I mean, so one of the reasons I built Validated was I just found that I'm working at a sort of medium scale. So I'm not working with really small data, and I'm also not working with really big data. So all of the data sets I work with are things that can fit into the memory of a modern machine. And so I use that to basically make my life a bit simpler, and just I'm working everything in Python. And so I just load everything. So for example, if I'm reading from a CSV, I just read it as strings. I do no interpretation yet, but using this Python pandas, which is very fast for that. And then all of the checks are then implemented directly in pandas. And so all the parsing to, everything is then done that way, and it's certainly quite a bit faster. So I'm not doing anything fancy like rewriting it in C. It's just using the optimizations that are already built into something like pandas.
Perfect, thanks.
I think you got some comments in the chat, Ethan, so you can check those also. But so if there's no other question, and of course you can still use the chat if anything comes to mind, but then maybe let's move on. So Patricio, you're up next actually. So Patricio is going to present the Tech We Want, which is our new initiative at Open Knowledge Foundation, which is really Patricio's idea to kind of like reimagine how tech is built today. But I won't talk too much about this because Patricio will be talking about it. So Patricio, go ahead, the floor is yours.
Thank you, Sarah. Let me share my screen. Share, and probably, can you see it correctly?
Yes.
Okay, thank you, Sarah. This is gonna be like a short presentation, just to kind of like change the mood and lead like for the discussion that we are going to have next. As Sarah mentioned, the Tech We Want is an initiative that we have at the Open Knowledge Foundation, and this is going to be a little bit of a provocative conversation, a provocative presentation. But the idea is to kind of like kick off a discussion, kick off ideas, kick off like, and start rethinking the way we build technology. So the Tech We Want is an umbrella project to rethink and put in practice the way that we are building software, and to be mindful about the sustainability of the tools that we are building. It's basically like an initiative that was born out of the frustration of the current landscape of technology, and how like everything become like super complex, and how even when it's sometimes like necessary, like how quick evolving all the landscape of technology is, and how like easily things get obsolete. I sometimes think that we are going to towards like a fast fashion paradigm of software development, with this like vibe coding and new JavaScript frameworks every 2 years. So that frustration lead to like, okay, no, let's stop. Let's think, how are we building technology? And let's have like an honest discussion about this. Mostly like between us, that we are not like big techs, that we are don't have like billions of dollars in funding. Can we create like a simpler technology? So as I mentioned, Tech One is an umbrella project. We use it like to do activities of like thinking technology, but also like put it in practice. And the discussion about the current landscape of software is like big. So I'm gonna narrow it to like a couple of examples to kind of give an idea of what are we seeing as a problem and what are like the discussions that we want to trigger. We want to build technology that lasts. I want to build technology that is not obsolete in a couple of years. So that we're always thinking about how are we building technology. And when we are building technology, I'm thinking, okay, the things that I am doing is going to be running in 15 years, or in 2 years it's going to be completely obsolete and it's not going to be possible to run it anymore. How much work you will need to put in 2 years to update your project? I mean, I'm building something in 2 years, it's going to be okay, or I need to put like $500,000 in like developers to update it because like the rendering mod engine of the framework change. How many of your dependencies will be deprecated in 5 years? I mean, are we thinking in terms of like, okay, are we going into the dependency hell with our project? Is this a risk to have so many dependencies or not? We have been repeating this mantra of don't repeat yourself in the software industry, but sometimes like maybe repeating is worth it. Another question that we like to ask and discuss is like, okay, are we building products or are we building infrastructure? Both are okay, but are completely different. One thing is building like a product, like Facebook, Twitter, like a web page, like a phone application that you want new features, you want to integrate customers' feedback, and you want to change it, adapt it, add new things. Another thing is building, I don't know, an infrastructure to publish data with a stable API. There are completely different kinds of softwares, and I think that the tools that you can choose to build products or to build infrastructure can vary differently. If you want to keep in mind that the software that you want is going to be stable and you want it to be running in 15 years as a public service, for example. Another question is like, okay, are we measuring the value of what are we building to ensure the funds of what we build? I mean, I want to keep working on this for like 20 years. So are we measuring the value? And as well, I mean, are we building sustainable and profitable projects? Which I know this is like a little bit like opinionated. Not all software needs to be profitable. But I think that the technology that we want and the way we build technology needs to start thinking about, okay, how are we going to ensure like a cash flow for it, even more in the current context where like international aid funds are getting like cut. So, I mean, we need to start thinking, and we need to be less afraid of thinking and talking about like money in the tech we want. There is like a whole discussion as well in like a lot of communities about, okay, how are we going to be sustainable in 10 years if we don't have like any funds for it? And lastly, another question that we always like, okay, if I want to build a technology that lasts, the technology that we are choosing is aligned with the long strategy of our organizations. I just added this question because last night we had a conversation. One of the reasons we are like rebuilding like the open data editor that Romina mentioned a couple of presentations ago is because like a couple of things. But one of these is like the technology that it was built on, it was only known by one developer, and it was not aligned with all the tools that we use internally in the organization. So when that developer couldn't work on it anymore, I mean, we couldn't like switch people, we couldn't switch developers between projects. We didn't have like this like capacity. So we decided to choose like a technology that maybe is like a little bit more boring, but is easier for like small organizations like us to be sustainable in the long term, because we don't need to compete with like talent in the jobs market. So some food for thought. We are not the only ones that are talking about this. If you are like interested in like sustainability of software development, looking the software as an infrastructure instead of a product, I recommend you to see like this presentation in YouTube, Building the 100-Year Web Service with HTMX. It's a tool, it's not the idea to promote that specific tool, but he talks about how can we build technology that lasts for like hundreds of years. He makes like the traceability with bridges, and how is it possible that we have bridges for 60 years, but our software gets obsolete after 2 years. So it's a really interesting like presentation. I encourage for you to see it. So specifically, the tech we want, how it impacted us. When we were building like the open data editor, one of our open source dependencies just disappeared. So basically, we were building like the application using like a React frontend, an Electron, and a fast API backend, and then we use Electron to wrap it up as a desktop application. We were using a React component to display the grid, and it disappeared. Literally, like the GitHub, it was an open source project, but the GitHub repository disappeared. The documentation page disappeared. And it's not that they deprecated and make it like archive. No, it disappeared. So then it was like, okay, it's one of our main dependencies of the project. We were thinking that because it was open source, it was reliable, and suddenly it disappeared. So now we need to rebuild one of our current components of the application, because we don't have the dependency anymore. This is clearly not the tech we want. And that's why also maybe we are going to like more boring technologies, but that they are like more sustainable. And then we know that in 10 years, they're going to still be around, because there is a huge community around it, because there is funding and so on. This is external, and you say, yeah, okay, this is not the norm. I mean, open source projects does not disappear, but I'm going to take it like to like a more known something that happens to us. So I'm going to expose like the SICANX validation case. SICANX validation is an extension of SICAN. For those who don't know, SICAN is a framework to develop open data portals that we at the Open Knowledge Foundation have been developing for the last 15 years. That framework has plugins or extensions. SICANX validation is one of these extensions. That what it does is when the user uploads a CSV to the SICAN portal, it uses frictionless data in the background to create a validation report and showcase it to the user. So you have like a validation when using the data portal. So in October 2022, so like the Open Knowledge Foundation, we introduced the frictionless components, which was like a React component project for the frictionless framework, as one of the core dependencies of that SICAN plugin extension to display the resource validation. So we did a migration, and now this extension is using frictionless component as a core dependency. And then on August 2023, this frictionless component was deprecated. So we introduced a dependency that deprecated less than a year later. So basically, we did like a change and like a pull request. We changed it like the core dependencies of the package, and then it lasted for like a year. Then it was deprecated. The component is now deprecated. No one is maintaining it. It was a core dependency of another package. Now that package is having like a problem, because who is going to put the effort to migrate it out of it? So this is not the tech we want. This is not, I mean, we need to make sure that the things that we build and that we create last more than at least a year. So to finish, the table one is not about like silver bullets or like recipes on how to build software, or maybe yes, I am quite opinionated on how to build software, and I think, I mean, I am an engineer, so I think that we need to start having like more hard discussions and hard metrics on how we build software. But I know that every project is its own world. So the table one is not about like how to build software, but rather like an invitation for an honest discussion around the way we are building technology to ensure that what we are building is sustainable, and can be used for like years to come. So thanks, and thank you all of you as well for like all the presentations on Frictionless. I always say it's like I really like the Frictionless and how it validates data. I think like as an open data activist, I think the validation is like the key issue that we need to solve right now. So yeah, thank you everyone. I cannot hear you, Sarah, if you're talking. But Kate, I see that you have your raised hand. If you want to ask a question, please shoot.
Yeah, first, again, great presentation. All the presentations today have been really good, so thank you all. First, I guess the expected answer, or yeah, like I should say, I agree 100%. And my thoughts on how to do this, like get the tech we want, would be, you know, simplicity, like less complexity, modularity, and strongly typed languages, things like that, right? But then let me push back and kind of play devil's advocate in a way, or maybe not even devil's advocate, but argue something different, which is that it might not be possible, right? Like you say, how do we create things that last? I would actually say maybe we shouldn't initially, but we should be more intentional about it. And what I mean by that is that when you're, especially if you're tackling a new problem, like what one typically does, and what I would normally try to do, is sit down and think about, okay, well, what do we need to do? What are all the problems we're trying to solve? Like, what should an API look like? X, Y, and Z, right? But what I find time and time again is that you can plan all you want and do everything right? But then when you get to the real world, like you realize that actually like things are different, or maybe the idea that in your mind seems like a good solution is not so great for unexpected reasons. And so instead, what I do now is that I kind of expect that the first couple iterations of whatever I'm trying to implement are just going to be thrown away. They're the fast fashion ones where it's like, I'm going to get something there, see how it works, get feedback, and then start for, like, just wipe the code base, like pick the little pieces that work well, but then write a new code base. And you do that a couple of times, and then each time it starts to stabilize more, because then you actually converge on a better solution, I think. And you can get out all the other things that like seemed useful, but just add unnecessary complexity. You can start to shed those along the way.
I don't know if you, can you hear me now?
Yes.
Thanks, Keith. And if anyone has other questions or comments, just go ahead. But we can also slowly transition to the other part, because Patricio's presentation was actually an introduction of the third part of the program today, which is basically like Frictionless Tomorrow. And basically have a community discussion on how we envision the future of the project. And to do that, we actually have selected some members of the community, and Keith is one actually, who will be kind of like discussion leaders and will kind of like bring interesting points forward. So we have Keith, as I just said, Pierre, presented before, Peter Smith, Stephen Diggs, Kyle Husman, and Phil Shum, who also presented before. So I don't know how you all want to organize yourself. If there's anyone that I just propose that probably we'll go a bit like free flow, and then whoever wants, and we just have a discussion, but I'll let the discussion leaders also decide on that, as they might have other plans. Yeah.
Yes, yeah. Maybe I want to react to what Keith was saying. I think there is a balance to strike, because there is also the question of the means you have to get to your ambitions. And for instance, I believe today that Frictionless had very high ambitions, which is nice, but also there are a lot of features that are like that have rough edges, sorry, and that are hard to maintain. There is a lot of code, and I would personally prefer something with a smaller scope, and with more ability to break things at some times, rather than this big scope. Even if we planned, for instance, to release a frictionless next version, I know that after the release, I will still have some things I will discover, and I'd say, oh, if only I had thought about changing it before the next version. So I agree with you that you have to keep some flexibility to change things when it's time, but also that you have to refrain from first refrain from doing it every time you see something that is not perfect, and also that if you have not a lot of means to maintain the code base, it would be nice to have a smaller scope, in my opinion.
Keith, you wanted to react to that, and then I saw also, Peter, that you had your hand raised. So Keith, you go first if you want to react, and then Peter, you can go next.
Yeah, I'll just say I agree 100%. This is kind of the point I made at first, where I said, like, the right way is, reduce complexity and kind of modularity. And so I think I'm all for it. Like, I think like we have a code base that is hard to maintain for little value, right? Like a lot of features that are there that probably no one uses, that make it harder for anyone to open up the code base and actually work on it. So the more we can decide what we actually care about and put our efforts there, and then simplify and get rid of the other things. I mean, if it turns out we might remove something by accident that is useful, and then we can deal with that later. But I think with a bit of planning, we can do a pretty good job and reduce a lot of the complexity, and then make it easier for everyone involved with the code base going forward.
Yeah, Peter, I agree with this, and I'm really happy you brought this up, this tech we need, and like the sustainability of what we do, because I think at the core, we have data package, which is a standard, which is the thing that is going to survive for 100 years. But coming into the Frictionless community, I find it, one, impressive how much such a small community is able to do in sustaining software. Like the number of people that are in a Frictionless call, they're not a lot, I find, for a community that has such a standard that is developing or is being used so much and is maintaining so much software. So I always have the impression we're stretched very thin. And that is why I think we should do two things: is reaching out to other communities who really rely on data package and build their own things, like JBIF. Mark Bagdan from OpenSci is here. Like, the more there is adoption, the more other communities will build things for you. Like the core group that is maintaining data package doesn't necessarily have to do it. And then, yeah, I think the other thing is, we've probably been a bit overly ambitious in what kind of software we need to centrally develop. We don't need to do data manipulation. I mean, there's excellent tools to do that. I think we just need to focus on the tools to read and write data packages, and other tools will be built by people on their own just because they have a software need. For example, what Ethan is doing. I mean, you clearly had a software need and there wasn't something out there, or you didn't know that there was something out there, so you built something. But yeah, I think we drastically need to reduce the dependencies, and I think the core thing to focus on is validation. And I mean, there is some plans to work on that, to have validation that could be used by any software language that is fast validation. But yeah, and I'm impressed by how much we have done as a community, but also scared how maintainable it is. So I'm really happy that this is being brought up.
Ethan, do you want to go next? And thanks for bringing this up, Peter.
Yeah, I wanted to build on what's been said, which is one of my thoughts is about sort of adoption within the community and sort of the tools that maybe we each have, or what we can show to not skeptics, but just sort of, I don't know, for me, it's just busy scientists who are maybe on the side scrambling to publish some data because maybe they're being required to now, or they would like to do it. And so I think there's of course the metadata standard as something that's fairly relatively simple compared to many very prescriptive ones that are very specific to different fields of study. But I think it's also important in the scaling down to still have kind of at least a demonstration piece of software that is really in sync with that metadata standard. Because I think there's been confusion with like, okay, it's like, great, this is metadata standard, but if there's no one place, and I think that was what the idea between Frictionless, the PY, and then there were others in different languages, but some sort of tool that basically supports the latest standard and all of the features in it in one. It doesn't have to be more than one, but just one place, because otherwise it's, like folks are confused, like, well, why, they want to have, I mean, of course, like I think the metadata should be guiding people towards information that's really critical to just contain in the metadata. And so there, I feel like units, for example, is still kind of a really open question for sort of scientific data sets, because we really want to make sure it's in there in some way. And so having it not even mentioned has been a concern, but then just having it actionable, at least in a basic way. And so I think but that the two are kind of always together. I think that is important to keep in mind as a goal.
Thanks, Ethan. Nick, do you want to add something to that?
Yeah, can you hear me?
Yep.
Perfect. Yeah, I agree with that. I think some work can go a long way, and it's not necessarily a technology. I put it in the chat, but the core columns that we talked about, people have already commented on how that's useful. I can tell you it's incredibly useful. The reason we added core underscore in front of it is because we recognize that we're getting data sets from all kinds of different places. And so it's a way of differentiating what the extra columns are that, in some cases might be duplicated.
Oh, now we can't hear you anymore, Nick.
Can you hear me?
Yeah, now, yes.
Okay, sorry. Yeah, and so a lot of our data sets are geospatial, right? So there's different geospatial standards that could be handled, including latitude, longitude, and Uber H3, and so on. We could probably agree on what those columns look like. We would have suggestions. Some of them are related to just handling the data, like who created it, when was it deleted, and so on. And I think some work there would really help us, because it does take an enormous amount of time to name things, and there's always collisions, and then we have to teach our applications about them and so on. And it's not a technology. So if we can agree on what some of these standards are, in some cases very open, in some cases very restricted, then I think that we would basically be creating templates that would allow us to share work with each other, that's scientific or otherwise. And I think that would really help. And it would last forever, because effectively we're just agreeing on the presence of certain columns that are named certain ways and validated in certain ways. So that's my pitch, I guess.
Thanks, Nick. Keith.
So this is very much in line with what I've been kind of arguing for in the past, of this idea that we could maybe think about having a multi-scale standard where, like, there are a bunch of different fields that all want to talk about time, or all want to talk about spatial coordinates. And we could see if we could find some of those like widely used kind of subsets and that we can agree on. And it doesn't have to be like enforced, but we could just put it out there as maybe suggested, like a suggested standard. And then within that, if you, again, like think about it in terms of multi-scale, like subfields could then build on that and say, okay, well, this is the starting point, and then we're now going to move within biology, and here's some other things that across the different biology fields, like we might want to agree on, like how we're going to talk about organism, taxonomy, ID, and that kind of thing.
Peter, yes.
Yeah, building on top of that, I find it very, I mean, yes, there's the mechanism to do that, but I find it hard to like centrally coordinate that, because those domain specific things are done by those domains and don't trickle back to Frictionless unless that domain is so engaged with data package that they want things in the core data standard. So yeah, I'm always trying to wrap my head around like how do we, or do we even have to organize this? And the other thing I wanted to mention is, in addition to all the software that we have and functionalities like functionality rods, is we have data packaging version 2 out almost for over, no, we're getting close to a year, but as far as I know, there's currently no software supporting it. So that's an additional task that we've now embarked upon. So yeah, we really need to trim down the scope, I think, of what the core the core group, or especially like what the Open Knowledge Foundation wants to support as engage and like find funding for and maintain. Yeah, I think we need to have a much more reduced scope for that and figure out what that scope is, I think.
Nick, you have your hand raised, and then Pierre.
Yeah, briefly, just to talk to what Peter just mentioned and Keith, we've spent years trying to figure this out because we're building applications built on lots of different data sets. And so the reason that we came up with this core concept is because it's in addition to whatever you currently got in your data set. You can call your name column or your ID column whatever you like. But what we're saying is you could convert that data set to include additional standard columns, which would be called core underscore something. And we do it for basic metadata handling of a file, but also geospatial, so time and space. Those standards are actually additional to whatever it is your native format is. And so that does allow us to create a kind of a migration path or a bridge from whatever people are currently doing in their domains, which we agree are, they're going to be their standards, whatever they want. But it at least acknowledges that these extra things could be present, and there can be a mapping from whatever you are supporting into this common standard. And it's very narrowly focused on geospatial and common standards, and it really has been helping us.
Thanks, Nick. Pierre, yes, go ahead.
Yes, I'm sorry, I don't want to talk about the vocabulary standard, so if I don't want to close this discussion. I wanted to propose, I have made some clustering of the features of Frictionless Pi, and maybe it would be a starting point to discuss a scope reduction if there is a consensus for this scope reduction. So yeah, it's a proposal, but I don't want to give an end to the current discussion.
Unfortunately, there are no reaction like give us a thumbs up, but I think you can go ahead.
I have a quick comment about the current discussion before we move on.
Yeah, great, yes.
I was just,
ahead,
I just wanted to say that I think one of the strengths, as Phil mentioned in his presentation of Frictionless, is how unprescriptive it is. Like, it provides a meta framework that allows us to encode, all like different domains can do what they need in order to adopt it. And I think if we do start thinking about creating taxonomies, creating standard, core columns and things like that, we need to be very careful that we don't fall into the trap that many of these other data standards have fallen into, where they become sort of overfitted to a particular field or a particular way of thinking. And so I would, as we are thinking about these types of mappings or taxonomies, I would really encourage us to think about what are the sort of meta concepts involved, and put into Frictionless the tools that allow us to build in those types of taxonomies or relationships with columns, or like, concepts and stuff like that. So that then fields can create their own hierarchies. So as Peter talks about, like, we can give the community the infrastructure, but then the community can do things that we've never thought of before. So rather than making it part of our scope to figure out what are those mappings of time and space and all of these other kinds of concepts, if we can figure out, I think maybe those are good places to start, to figure out what are the meta concepts that, what are the meta capabilities that we need to put in there in order to make those mappings possible. But I would want to avoid, or I would want to make the mapping out those actual domains and spaces outside of the Frictionless scope, and make that like its own community effort or group or federation of efforts, if that makes sense. So that's my closing thought, and we can move on to the other scope stuff that Pierre was talking about.
Sorry, because I see also Amber has hand raised. Amber, is this related to this, or?
Yeah. Actually, I was just like really enforcing
Sorry,
that flexibility has been very useful for us, and we have exactly implemented, as he's saying, using these flexible standards to, implement our checks for our own naming conventions for our particular interoperability rules, and taking the approach of not enforcing names but mapping to standard vocabularies, like NERC BODC and the Darwin Core, like LSI scientific names or verbatim identification. So that is how we've tackled that, and I think if that's your goal, is to have a system where you're enforcing names, you could do that too,
Thanks, Amber. If there's no other comments regarding this, I think, Pierre, your time has arrived.
Okay, thanks. So I'll share my screen. Okay, so this is a work I literally made half an hour before our summit. I've put it in the Frictionless Python framework roadmap discussion, which is on Frictionless Py discussions tab, and it's a coarse-grained clustering of the features I've identified in Frictionless. I may be missing some features because I'm relatively new, despite maintaining it to some of these features. For my use cases, I've mostly used the validation features. So sorry if there is some errors on the other features, but I wanted to have some view of what is supported today by Frictionless, and here are the results I found. First, there is, for me, the main functionality of Frictionless is the ability to validate data against its metadata, and also to manipulate metadata. So it not only validates that data follows a data package or table schema specs, but also it validates that data is well formatted. For instance, if there is a field missing in some CSV, it can validate it even without a schema. By doing this, it infers implicitly a table dialect, so I can validate CSV with a semicolon with a comma as a separator. and it can validate a wide range of formats from a wide range of sources. Then there are several. So to do this, I've taken the command line client and I looked at the documentation mostly. There are some command line commands to facilitate data and metadata exploration, to see the data, to query the data. For instance, frictionless query and frictionless script are creating respectively a SQLite database and pandas and pandas data frames to manipulate. So if you enter frictionless script and then your data package, it opens a Python Python shell where you can explore these data frames. Then you have frictionless extract, which builds upon the ability to read and validate a wide range of formats. So the frictionless extract can retrieve the data from a given source, remote source or a SQL database or whatever. Then there is frictionless list, which simplifies the metadata and lists the resources inside a table schema or data package descriptor. There is frictionless explore, which is an interface with Visidata. I am personally not sure about the added value of this because I believe a Visidata user would know how to open the data, but maybe I'm missing some details on what it does behind the hood. I've identified some features around data transformation. For instance, there is a frictionless convert, which offers the conversion between different formats. I couldn't get it to work, so I'm not sure it is working or if I missed something. There is a frictionless index for database indexing, so I'm also not sure about the use case of this one. And then there is no a command line interface for this, but you can make pipelines and use the Python transform function for to define a transformation pipeline. So there should be a way, maybe directly in the metadata, to use this at the command line. There are features for one feature for data publishing, frictionless publish, which can publish to CCAN, Zenodo, and GitHub. And at last, there is format inference. If you don't have a schema, you can ask frictionless to infer some formats. It prints the columns and it infers the associated type. And one use case I could see for this is that with the JSON tag, it allows for getting a starting point for table schema and table dialect. So as I said, I may be missing some features, but I think it could be a starting point for the discussion if we want to reduce the scope. What do we keep? What is not essential for the frictionless Pi software? Yeah, and maybe I'd like to know what is used by the community. So as I think Kyle shared, I think every feature will be somewhere used by the community, but what is widely used and what could be replaced by some other tools.
Keith, go ahead.
So I don't have an answer to what we should keep and what we should remove right now, but maybe a good starting point would be for those of us who think this is a good idea and want to try to take it on together, to plan like a splinter working group and meet once a month or so. And the first time we could just, like review this list, and each of us could kind of try to spend a little bit of time to decide what is important or what's not. And then we could decide on next steps from there. And then each month we could check in and see. So I was originally thinking of this in the context of the core functionality idea. And so maybe we can kind of combine these. So deciding on the core functionality while also slimming down on the things we don't need. But it would probably take, more than one meeting to figure it out. But just having a timeline so we don't kind of say like, hey, this is a great idea, let's do it. And then like 6 months go by and nothing happens. I think we need to actually like set up some kind of timeline and then set some small goals to start working towards it.
Phil.
I think I agree that I think this is a great summary. I do agree that I think it's difficult to just right now sort of either elevate or chop things out, because I think each of us would differ a little bit. Peter mentioned validation, and I do think that on some fundamental level, data validation is really critical, and it's also something that that I think the data it should be seamless between that and the data package standard in terms of sort of the way that works. So I see that as kind of different from those other things that were listed, each of which actually has a very specific sort of task or goal behind it. The data validation should just sort of be there in the background and available anywhere in a very performant manner, it seems to me. Everywhere from being able to use typing or to use it in kind of a typing context, to using it in all kinds of different contexts. I guess the one thing, and I realize that maybe this goes back to the previous discussion, and if so, I apologize for that. But I think we've sort of said that our resources are going to be limited, and we've seen examples of many people in the community already developing a tremendous number of things. The question becomes, where can we add the greatest value? And I think, clearly, the decision for the data package standard to divorce that from the software and even from the frictionless branding, I think was absolutely key here. But I also think that areas where we and here I don't, so I am not a software engineer by training, so I'm not thinking about me specifically, but certainly the software engineers in the group. One place where we can add a tremendous amount of value, I think, is in one, having a core library that is carefully designed and thought through and maintained, that everyone else who seeks to build tools can build on top of. That's something that's very hard for an individual to create, and definitely for a non-engineer to create, but which, if it's done well, can be really easy to use. And then I think the other is, examples, whether they be, templates for creating plugins or things like that, that make it easier for a person who's doing the extending to do it in a way that is, that is best practice from a software perspective. Because most of those people doing those extensions are not going to be software engineers, or they're going to be part-time software engineers. And so I think those are two areas where we can add the most value, and make it easier for people to then take that and go forward. And so I think, just to finish up, I think part of, and I think this was kind of what Keith, I think, was saying, this question of what do we keep, what do we drop, or where are the most important things. I think there's another dimension, which may not be orthogonal, but is related to that, which is if we were going to create a core library, what components would that have, and how would we make it possible then for people to add back the kinds of features we're talking about, possibly in a native sort of way, native to their domain or to the analytic software system they're working within, but that would guarantee, to the extent possible, interoperability and ease of maintenance going forward, those kinds of things.
Peter.
Yeah, with the risk of repeating myself, but for ChemTrapDB, we have an R package that provides core functionality for ChemTrapDB, and that is reading, up converting from an old standard to a new standard. So for example, for data package 1 to data package 2, validation and writing. And I think that's like, and the reading is, of course, reading the data package JSON. What I also including there is, since data package is so strongly tied with tabular data, it can represent more data too, is also reading tabular data into something like a data frame that then can be pushed to SQL or pandas, but like that doesn't necessarily need to be part of the core functionality, but have a tabular expression in that language. So read, validate, write is what I think, and upconvert is what I think, to me, is part of that core. There might be other things, but yeah.
Steve.
Hi, at the risk of taking everybody away from a technical focus and a very insider view, I think when we talk about this topic of the future of the project, one of the things that we don't have to do is sell it to the insiders. Its technical merit, the applications. I think that the future of the project will probably rely on broader appeal. In other words, there's lots of people who don't know that they need this, that need it, and approaches to them. I was in a meeting all week. For those of you who may or may not know about Zenodo, we're a co-developer on their Invenio RDM platform. And the discussions tend to veer toward the very technical, because that's where a lot of software engineers are very, very comfortable, to the point that we had a merge party. Now, they couldn't get more nerdy than that. We had 97 merges and people were very over the moon, but we did not really make an appeal to people who may want to adopt that platform. And so the conversation turned toward sort of a estimation of demand. In other words, what potential communities do we want to appeal to, and what do those appeals look like? In other words, let's suppose that we're just talking about two particular facets of this project: the library itself, Frictionless, and the data packages. What communities need data packages that don't know it? How many times have all of us gone and gotten a data file that we wish had data packages, and we had to struggle through in the old-fashioned way of maybe picking through a README file, reading a documentation, contacting the data originator? These are all things that Frictionless fights to reduce. And so what approaches could we take as a community to reach out to other communities to not only broaden the usage, but to bring in new perspectives and voices to help develop the various aspects? And then I think there's a broader discussion to be had about how do we message and tout the entire philosophy of Frictionless as a very useful thing. I think out in the out in the real world, there's still a lot of friction that people are just sort of self-imposing, and they don't need to. And I think this project could go a long way to mitigating a lot of that friction and getting a lot more information out to a lot of people much faster.
Thanks, Steve. And I agree 100%. One of the things that we've been discussing also and that Peter brought up before was, for example, as in the case of the CamTrapDP, the fact that they wrote an academic paper really changed the game in terms. So we've been talking a lot about maybe doing the same for data package. But Peter, maybe you want to add more about that.
Yeah, it is hard. It's three different hats that are being worn here by this community. One is we're a standard organization. I mean, we're not, but that is what we're doing with data package and like moving towards versioning of a standard. Then we're software development organization where we want to make it easier to convince people to use data package by having already easy to use tools, because that is what's going to convince a lot of developers to adopt Frictionless in their workflows. And then it is to not necessarily developers, but like users that work with data to explain the concept of frictionless data. And yeah, please document your data. There's going to be a lot of readers. There's lots of outreach that can be done there. And I think, especially for point 2 and 3, we need to rely on other communities to do that work, because it is not scalable to do this by the group that is present here. And yeah, I think that is a work. I mean, each one of us, I'm sure, is part of this community, but also part of other communities that might use Frictionless. And that is work we have to do in both. So yeah, agree 100%. It's a big task doing those three things.
Yeah, but very necessary. Phil, you also wanted to add something.
I did?
I don't know, your hand is raised.
Ah, well, then it shouldn't be.
Okay.
I don't know how to unraise my hand, but
no worries, I can do that for you. But Ethan also wanted to add something.
But I think just reacting to what Peter said, you know, for those of us in the U.S. or affected by the U.S., we see in the news a lot of people doing things that horrify us, like, oh my goodness, the government's coming for my data. I think I should throw it in the closet. Make a copy. I think I should have people who are not in my discipline copy gigabytes of my data and hide them on Google Drive. And we would all agree that that approach that is more like data packages would make us less horrified by that concept, because then you would be able to untangle the ball of string. I see Amber's on the call, and I was just wondering if people were going to this site and grabbing their data and hiding it away. I think that for all of us in the know, we know that this makes the problem worse. And yet there are concepts out there, Frictionless, of course, is one of them, where data are meant to be in the hands of people who don't have the domain expertise. They may not have the instrumentation expertise, but that's all in there, so that these things can be put back together. So there's a use case, and there's unfortunately, a market, if you will, and overwhelming demand to use data packages wherever we can for all the data that will always be at risk. So not just the winds of politics, but we did have a situation in oceanography, and it was very ironic that the number one place in the nation that has hurricane data got hit by a hurricane. And those data went offline for weeks and needed to come back online. And I know that one of the things that NCEI does not have is wide use of data packages. How would we make a broad appeal to them to join this community? I think that's something that's worthwhile.
Yeah, thanks, Steve. Ethan, you wanted to say something, right?
Yeah, and I'm responding to a few different things, so hopefully it won't be garbled. Yeah, I think the direction going forward in ways of I guess increasing adoption I see sort of a few, couple complementary strategies. I think one is to really continue to strive for the quote good enough, data practices, which is, it's a term also has come up with software, good enough software practices, to sort of look at the basics right, because and I think that's especially relevant to more of the kind of solitary or small projects, or in the sort of scientific disciplines, like not the big institutions, the big data repositories that have their own standards and so on, but more the, let's say, the scientists sitting down and, again, like, okay, I need to get this data out quick. How do I do this and not have it completely stuck? But there's this other side, which seems to be rising, and I think it's a really important direction, which is actually establishing more prescriptive standards, but built on frictionless. And we've seen some great examples of that here. And I think that's a really interesting direction to take, because first of all, it's kind of doesn't cost very much in terms of, like, it's not, it's a natural evolution, and it makes it, it's a very powerful tool for then having a huge adoption in certain specific communities. And I've been a bit disappointed, I guess, in some way. I mean, that, or I think that could be something that could be a focus or guidance for the future is, if we're going to focus on validation, which we've all seemed to agree on, that's core, then, in what way could we, one place where I can see actually expanding slightly is like making it really easy to validate against a remote, a remote data package or table schemas, in maybe a somewhat more central way. And there's been, sort of technical issues with, like someone's preparing data and then they want to make sure it matches a standard, and not have to rely on the validator website, like just having it be I think that could be a core. And then we've talked about reading, and I think that could be a lot of what could be cut is, the data has to be read because it has to be validated. And like, what's the minimum way to do that? One of the reasons that frictionless POI is slow compared to reading a CSV file with pandas, which is actually reading it with some C code, often, is that, the reading is actually extremely slow. It's not the validation itself often. And so I mostly don't use tools like anything that, I almost always end up reading the data myself, and then having to sort of carefully cast, or like writing custom code to cast the types in the pandas data frame, rather than doing it through the frictionless package, because it adds a lot of dependencies to a project to have the frictionless package there. And frankly, I have everything in them. It's a lot to add to just be able to read a few CSV files way more slowly. And like it seems like it's certainly good enough if frictionless could very fast read the data from, let's say, CSVs, or a few data formats that are considered to be high priority, I guess, and into a very basic data structure, maybe just a list of lists or whatever, that is then trivial to pass to pandas, or is trivial to pass to Dask or Parquet, whatever you want to use ultimately. And so I think reading should be done as far as it's necessary for validation, and mostly focused on that. And then I guess I'm curious what people mean by writing, and if you mean only like writing metadata, or and why that's necessary. Like, I'm curious what people meant by that.
Do you want to go next?
Yeah, can you hear me okay? My microphone stopped working. Oh, okay, thank you.
Yes.
So I wanted to add one thing to what Stephen said, because I think that was absolutely terrific. I just wanted to add one thing. I think another really important community for us to consider are the folks who are themselves creating things that overlap with Frictionless. So they're either creating data sharing platforms that have kind of absorbed, some of this. So, OSF would be a good example of that. Or people have created other standards. I think, there's no point in fighting with any of them. It seems to me that in most cases, with possibly a small amount of effort on our part, we could simply make sure that people using Frictionless could seamlessly move back and forth. And I think we'd get a fair amount of cooperation from those groups. But I think it's an additional really important user group that it's easy for us to ignore when we sit around working on Frictionless, but we need to make it easy for people. We need to accept the fact that there will be preferences and so forth, and be agnostic with respect to some of that, and just make it as easy for people to use Frictionless in as many contexts as possible.
Yeah, 100% to what you just said, Phil. And Amber, you wanted to say something.
Yeah, following on Phil's comment there about getting more adoption and broadening our community and more people using it, and looking at the barriers to entry there, I think one thing that's been a challenge for us, that maybe this is some kind of more education resources that might be part of it, is formatting the data for import that's compatible to get it into all these schemas and systems. I don't remember Adam's screenshot, we get a variety of things, often with like spreadsheet formatting that cause issues, or like configuring the load steps, and like considering like if there's some AI tools that can help with those load configurations to make it easier for people to get data into these systems. So that's just something that we've been thinking about, and maybe there's a solution in terms of good, better, best education, like Ethan was mentioning around best practices too. Thank you.
Thanks, Amber. Steve?
This time I actually meant to raise my hand, which is convenient if you're going to say something. So yeah, combining what Amber just said with what Phil was talking about, I think that one of the things that we envisioned early, one of my current projects is doing automatic curation using commercial large language models. And when they're trained to a point in a discipline such as climate and marine science, you get some pretty good results, to the point that you can automate writing README files. You can automate building external data dictionaries. You can automate, I think you can see where I'm going here. Some of the components that would go into a data package can be right there. And it's not a big conceptual leap from that point to have, let's say, not only Bicodemo who's doing it and making data packages. And Amber, thumbs up, thumbs down. Data are stored as data packages at Bicodemo, or is that intermediate use for the data managers? Yeah, okay, yeah. But what if larger repositories were automatically, creating and storing things as data packages under the hood, almost invisible to the users, by creating the minimum viable product and always making things as data packages, that there's just zero exceptions. The reason I say that is that we did a little thought experiment a couple of days ago at this workshop. We couldn't find a good reason not to make a data package, that it was always a better idea. Just as in, you should never document your code is not something anyone ever says, but it's something that quite a few people often do. So maybe taking Phil's idea and Bicodemo's actual example, using that as a model to say this community could actually do, really kind of force multiplied good if the concept and the tools to make data packages were integrated into their daily operations.
Amber, go ahead.
Yeah, thanks, Steve, for pointing that out. And people who work with us may have seen that we just had a big new website release, and that's years of culminated things of our team's hard work to make a lot of architecture changes. And Adam pointed out how valuable the data packages have been for us internally, and we're planning to roll out even more access tools. And this I think, to your point, Steve, making that the context around sharing these data package JSON files themselves, in addition to the files, the data tables, is on our radar as well. It's just, we're getting there.
Yeah.
Yeah, maybe so. The summit will maybe end in 10 minutes. There is maybe one point I would like to discuss. I think it was Keith that said, yeah, we could do a working group to discuss the reduction in scope. I have a lot of questions on how are we going to do this reduction in scope and this core package, and with what funds, and yeah, and so very practically, I was wondering so what we could do for the next steps. So with a very technical point of view from my part, so if I need to make changes on Frictionless, what can I do in the coming months, in what fashion, and yeah, so open question. Because I strongly agree with the discussion that is being continued in the chat about a small scope. I agree, reading, validating, describing looks like a good scope to me. However, there are already a lot of users. I don't want to like throw everything away and say now you should find an alternative, or yeah, not all at once. And if we develop some frictionless core implementation, there is also some work to. So what would be frictionless Pi in this case? So would it keep all its functionality and only use the core for the core functionality? That's all the kind of question I have.
I think Keith, you wanted to say something?
Yeah, I was just going to say we could maybe choose a date in a week or two, and those of us who want to push on this core idea could meet then and try to hammer out exactly what you're talking about. One possibility would be to create a new package, maybe both for R and Python, and say, okay, we're not going to break things, but we're not necessarily going to support these going forward. And we're going to consolidate on this kind of core functionality for the future. Also, it's a lot nicer to write new code than to deal with legacy codes. We could kind of learn, create a better API from the get-go.
Yeah, if it's not throwaway code that we that we throw away in 2 years to start over, but yeah, sounds like a plan.
Ethan, you wanted to add something, and then Phil?
Yeah, I guess there's sort of two different ways of dealing with it in a very broad sense. I live in a cooperative community. Anyway, it's a bit smaller, but like, for example, let's say we decide we have too many mugs, so, and in those contexts, often the best thing to do is just to take all of the mugs out to a new place, and then the mugs that people want to keep, right? They grab the mug and put it back on the shelf, and the rest get. And so that could be, I think, maybe the better is just to start from, this blank slate, and then you're basically like, what actually stays versus what goes, or like, so basically additive rather than subtractive. I think if there's going to really be that strategy, then I think it's a good opportunity to, for example, if they're implemented in Python in R, to have them sort of, I don't know about the R one, but in the Python one is a bit exotic in terms of the documentation. It doesn't sort of follow the way that typically Python functions and classes are documented, and which is a bit, I think, is a bit of an obstacle for. I mean, like also in IDEs, like what argument can I use in this function? Like it's a bit, somehow not modern in that sense. It doesn't follow some practices that I think most Python developers that would want to be building off of it expect. And I still wonder, like, could there be some? This is a bit, maybe we don't have the skills in the group, but like, would it make sense to have something like very fast core that is basically command line that can be called from under the hood from R and Python? I don't know, in terms of planning for the future. I'm not sure if that's maybe this very ambitious.
Thanks, Ethan. I love the cup analogy. I think that Phil also wanted to add something.
Yeah, just briefly. I think that, I mean, I would like, maybe even for us, since we're going back, consider the possibility that, something like a core written in Rust, or something like that then is very, very easy to use from wherever else you are. I don't think we should limit ourselves, I guess, is what I'm saying, in terms of, in thinking about that. But I do think that thinking about functionality that is designed for others to use, as developers, basically, as opposed to only us, even if we or some subset of us, then also creates our own command line tool around that we want to do. That leads you to thinking about things, I think, in a very different way. And I'll be really interested to see actually what this group and others who might want to participate, what ideas they come up when they start thinking about the development that way. So not as developing an end user tool, but developing core libraries that can then be used. And there's no reason, I mean, I'm pretty sure, certainly from things like, the areas I work in, there's no reason to have implementations, and, you should be able to link to or call out to a single library written in one language, I think.
Thanks, Phil. We just have 2 minutes left, so I think we'll slowly start to wrap up. First of all, I wanted to thank everyone also for the patience of staying here for 3 hours. It was a great discussion. I think in terms of like next actions, maybe, I mean, there was already a proposal in the chat, but I probably think we can try to form 2 working groups. So one would be around simplification, kind of like building a core functionality. And that's what Pierre was talking about. And also to the points that was raised by Steve, I think it might be worth it also to try to build a kind of like working group working around adoption and maybe communicating a bit better the project, which is something that also in the community we've been discussing for a very long time. So my proposal for you would be that I'll send everyone a follow-up email on Monday proposing maybe kind of like poll to choose a date for a first meeting of the 2 working groups, and then we'll just kickstart it from there. We can have a first meeting in a couple of weeks, something like this, so you have time to, you know, sort of like brief after this very long meeting. And then, of course, we can have conversation ongoing in the community chat. In case you're not there, there's a link in the meeting notes, but I'll also put a link in the chat early on. And yeah, unless there's any additional comment from anyone.
For organizing this, and thank you all for participating.
Well, thank you all for participating and bringing up these very excellent points. See you all in the Slack channel, and you'll receive an email to reconvene in the 2 working groups soon. So thank you all. Have a very nice weekend and see you soon.
See you all. Have a nice weekend.
Bye.